Okay, we want to look at how the y-factor of the slope graph is related to the y-factor of the original graph. Now, of course, we're assuming that the slope graph is of a power function is a power function. So I better write that assumption down. Assuming slope graph of a power function is a power function. If it isn't, then what we're doing doesn't make any sense. So we would really need to establish this. But let's assume that it does and see where that leads us. Okay, well, I've got a few power function graphs here. They're basically three shapes a power function can have: concave up, concave down, concave up increasing, concave down increasing, and concave up decreasing. You can't have a concave down decreasing. So I'm estimating, okay, now these are just approximate, just estimating what the y-factors might be here. And of course, we've done this. I've given you graphs of power functions and their slope functions and asked you to look at this relationship. So we want to just kind of summarize what we might find if we do that, or what you might have found when you did that. Okay, so let's say the y-factor here is 1.4, and we find by construction that the y-factor of the slope graph, which is in the same color, is 0.5. Then on a graph of the y-factor for the slope graph, which would be the f prime of x graph, versus the y-factor for the original graph, the f of x graph, we would have the point 1.4 here, 0.5 here. Then, if we have a y-factor of 3 and we find that the y-factor of the slope graph is 2, and I'm not saying that that would actually happen, but if we did get those numbers, and they might be not even particularly close to the actual numbers, then we would have, say, 3 out here, 2 would be up here, and we'd have a point way up here. Now, it appears that the y-factor of the slope graph is decreasing when the y-factor of the original graph is decreasing, and it turns out that that is the case. The question then is, if we draw a graph of the slope, let's what if this graph is a straight line? Not saying that it is a straight line, and I really don't think that it is, that we could ask at what x-coordinate this thing intercepts the horizontal coordinate where we intercept the axis, and that would be the y-factor that gives us a slope graph with a slope of 0, and that would be a horizontal slope graph. Well, if this is 1.4, then this is about 0.7. That'd be about 0.5. Okay? But this graph could have another characteristic. It could be concave up to the extent where you don't even get a slope of 0. Okay, because you can't have a negative y-factor. Actually, you could, but it wouldn't be a power function, and I don't want to go into that. Or it could be concave down, and maybe it looks like this. Okay, so interesting question. Where does the y-factor for the slope graph become 0? What's the shape of this curve? And furthermore, from the values we have here from a y-factor, we can get the value of p as we just saw. The power p that corresponds to the original, and the power p that corresponds to the slope graph. So what power p goes with 3, what power p goes with 1.4? What power p goes with a y factor of 0.5, what power p goes with a factor of 2? We can just plug that in to the equation we use to determine p in terms of the y factor, and we can translate this from a graph in terms of y factors to a graph in terms of p. So this is the y factors. Y factor slope graph versus y factor of the original. Left out some letters there. Or here, the power of the slope graph versus power of the original. I don't know why I keep wanting to original. Okay. Don't know why I keep wanting to write those letters wrong. I know perfectly well how to spell original. Got two O's, right? Okay, well, anyhow. You can go from one of these graphs to the other very easily. So what's the shape of this graph? Now there's an uh-oh here. That's for graphs that are decreasing. Okay, if a graph is decreasing, you got a y factor here and a y factor here, and that doesn't match up with what we have over here. And we want to figure out a way to patch this up. In our picture of y factors, and if there's no way to patch it up, then we kind of have an inconsistent theory. So I'm not going to address this right now. We'll address this as a class and see if we can figure out a way to patch this.